Okay, welcome back. This is probably going to be the longest video in this series. This is going to be actually coding the algorithm to generate the agent that will play the game and the model behind it. So yeah, not much to say. Let's get into it. So basically what I've already done is create a file called test2.py. It's blank right now and we're just going to start writing in it. So first we have to import all of our libraries. There's going to be OpenAI Gym, NumPy, OpenCV2, there's going to be Neat, obviously, and then Pickle, which is basically going to be how we save our model after it reaches a certain point, which I'll go into at the end of the video, most likely. Then we're going to import random, import noise, which is the file that we made earlier, which just adds noise to the image. And then yeah, that looks like about it. Okay, so first we're gonna create our environment, gym.make, and it's gonna be video pinball. Okay, you've done this before if you've watched the earlier videos in this tutorial. So yeah, then we're going to create what is called image array. Okay, sorry, just had to check something real quick. So image array equals, so it's just going to be a blank array for now. Okay, so then after that we're actually going to start making the function. So basically this function is called def eval genomes, and it's going to hold two parameters, which are genomes themselves and the config file. The config file is what we created already. I mean, most of this is just basically mapping to variables instead of actually, using them here. So what we're going to do is for genome ID in genomes, we are going to create a variable called observation, and this is going to be the observation for the current loop in the so this is going to reset the observation back into the start after it has ended another time. So once we do that, we're going to create an action, which is basically just a sample, and that's going to be, actually no, we don't need to do that. We are going to create three variables, which is the input X, input Y, and the input color, which is the color channels. And that's going to be equal to env.observation underscore space dot shape. So basically what we're going to do now is we're going to scale down the image. Instead of inputting 120 by 200 something, that's going to be a ton of input data. We're going to input a lot less than that. So basically what we're just going to do is in x equals in x divided by 8, and practically the same thing for the y. So once we do that, we're going to actually instantiate our neural network. So that's just neat.nn.recurrent recurrent, I can't spell for my life. That's right. Nope, that's wrong. Yep. Okay, recurrent network dot create, and we're going to use the genome, the current genome of the species out of genomes, and we're going to use the config file. Okay, after that we're going to set our current max, actually no, we don't need current max fitness, sorry, fitness current is equal to 0. So basically what the fitness is in this case is going to be the score, like I was talking about earlier, and per iteration we're going to just we're going to keep track of this fitness, and basically each time the loop is run and a new reward is added, it's just going to be compiled onto the fitness current, and we'll do that in a later step, but that's basically what this variable is. So we're also going to set frame equals to 0 and counter to 0 as well. So we're just going to set done to false because, you know, the program needs to run at least once before failing. And then while not done, we're going to increment the frame plus equals 1. So then now we're going to set a variable for our factor. Factor equals 0.5 or 0.5. And this factor is the same as the one that we put for the noise screen. So basically, instead of having, you know, a distribution with, you know, 100% altered values, we're just going to split that in half. It's just the way that we do that is just observation is equal to np.u and 8, and then we're just going to call noise.noisy and observation factor. There we go. That's the observation. Okay, now we're going to resize everything. Observation equals cv2 dot resize the input data and the new dimensions, which is, if you look up here, it's just the original dimensions divided by 8. Okay, so once we've done that, we need to convert it to black and white. So we're going to do cv2 dot cvt color. Now we're going to change it from an observation in color to an observation in black and white. Now the reason we do this is because if we have a color observation, that means that there's going to be 3 added dimensions of data. Now these dimensions of data are going to be, you know, red, green, blue. And there's really no added value that adds to the model. It just makes it train a lot slower. So there's really no point in having that, and we might as well just make it all, you know, grayscale, so we have one dimension of input data. Okay, now we're going to set image array equal to np dot nd array, and that's the observation, and then the output, oops, sorry, I did that wrong. Image array nd array dot flatten. There we go. So basically what this does is, instead of having an array with multiple dimensions, it's just going to put it into a one-dimensional array, so that way it can be fed directly into the neural network. And we do that in this step here. So neural network output is equal to net.activate image array. Okay. So then the numerical input, sorry. Can't type. The numerical input is going to be equal to output dot index max and output. Okay, there we go. So then after that, we're going to do yes. So the observation, the reward, done status in the info for the actual step. So env dot step numerical input. So basically step is just gonna run the next sequence in the actual emulator. So if you step each time in a while loop, it's just gonna like continuously run out the game until it's done. So and then each state is gonna have a reward based on, you know, if the action was good, if the action was bad, and that reward, like I've said so many times, is the score. Okay, so basically we're gonna do the fitness current. Fitness current is going to be plus equal to the current reward. So, don't know what that is. Reward. Okay, so then if the reward is greater than 0, then we'll set the counter to 0. But otherwise, we're going to set the counter to 1. Or, no, sorry, plus equals 1. So basically, this is going to keep track of how many times how many frames the program has run without a new reward being added. So basically, what we're going to do now after that is if done or counter equals 250, then we'll set done equals to true. So done is going to be is a variable set by the actual gym library based on when we step it, when we call the step function. So the step function is going to automatically determine if the actual game state is over, but the reason why we have counter equals 250 is so if no reward is being added, then we can just terminate that iteration of the game and it won't run in a loop forever. So say you're trying to train overnight and you can't really be looking at your computer, you can just have a cap of 250 frames. So anyways, done is going to be true, and we're going to print some data, which is going to be the genome ID, which is based on how many you have in your population, as well as the current fitness. So that's the score. Then we're going to set the genome.fitness is equal to fitness current. Okay, so that's the bulk of the function. After that, we're going to set the config equal to need. Okay, well basically this is the meat of what everything, what's going on. Lines like this and this, that's all behind the scenes in the library, as well as this. There's a lot of information on the actual documentation for this neat library that I suggest you look into if you want to learn exactly how this works and not how to implement it, so to speak. Okay, anyways, we're going to set the reference up for the config file as neat.config neat.default genome, neat.default reproduction, neat.default species set, neat.default stagnation. Okay, one more. The actual link to the file, which is config feed forward.txt. Okay, so then we're actually going to create a instantiation of this function, which is going to be p equals neat.population config. Okay, that was a lot of talking, but we're almost done. So then we'll just add a reporter, and here, I'll explain what this does in a second. Reporter neat dot check pointer 10. So basically what this is going to do is after, I believe, every 10, I want to say 10 generations, it's going to save a checkpoint. So that way, you know, if your program crashes, then you don't have to restart it all over. You can restart from a checkpoint. So, you know, it's basically just to, you know, keep safe. Okay, and then finally, winner equals p dot run eval genomes, which is the function. Okay, so after that, we're going to use the pickle library. We're going to say with open, and this is where you add any file name that you want. Blah blah blah. We'll just say winner pinball 1 pinball 1 dot pkl, which is the file extension for pickle, and then this is obviously going to be a write to file as output pickle dot dump winner output 1. Okay, that's it. So let's see if this works. Guarantee you there's going to be some bugs, but you know, let's just hope for the best. Fingers crossed. Okay, let's see where the first error is. Waiting. Okay, genome is not defined. Line 21. Where is that? Genome. Okay, let's see. Line 21. Ah, there we go. Okay, so instead of for genome ID, so genomes is actually a tuple. It contains an ID and the actual genome itself. So yeah, this is about it. So this genome that we reference here is from here. Okay, let's see if it works this time. Hopefully it'll work. Okay, let's see, line 35, c2.resize in x and y, integer expected, got float. Okay, so I think what I'm assuming is happening is when it's being resized, it doesn't divide evenly. So I'm just going to put an int around this, int around that, and call it a day. Okay, hopefully it works this time. Okay, as you can see, it's running. So it's gonna keep getting 0. Here, actually, I should probably render this. So